All right, so we are in Algebra 2, Lesson 8-7, Graphical Exponential Functions. So today's only exponential functions, which feels weird, right? Because last unit, Unit 7, was exponential functions, and then Unit 8 is logarithmic functions. So why the heck are we talking about exponentials right now, right, Chris, on your phone? Right, Chris, on your phone? Chris, do I have to take away the phone? All right, so we have these two standards. Today's date is April 30th. 2019. So let's talk about the parent functions. Parent functions are the easiest possible function. Let's talk about these two. F of x is equal to 2 to the power of x, and g of x is equal to 1/3 to the power of x. So generally speaking, there are always three easy points for any parent function. The first easiest is 0, something.
0.
Good guess. But one person has said it correctly in the class.
One.
I said it.
I said it.
I said it first.
No,
I
you
said
didn't.
it first.
It is 0, 1. Quiet raise hand. Who can tell me why?
Oh.
Nope.
Gio, go for it. Gio.
What the
This is,
heck?
I don't know.
No, why you gotta do
Plug it
that?
in, Gio. 0. 2 to the power of 0.
Oh, it's 1.
Yeah, there it is. Yeah. So 2 to the power of 0 is 1. Yeah. Okay. Thank you, Gio.
Wow.
Would you tell us what it is? It's just like, oh, because I overthink.
Stego, you get XP also. All right. So that's one of the 3 points. Here's another one.
Is it one more?
1, blank.
Zero.
Quiet raised hand. Quiet raised hand. 1, and you're thinking I plug in 1 for x. When I plug in 1 for x into that function, I get out, Fiona. Yes, 2.
Yeah, did I not call it? Of course.
1, 2. As I'm writing these down, let's go ahead and graph these points also. So 0, 1 is right here. Make them big because there's a dot on top of a dot. 1, 2 is right there. And there's also, my voice is starting to die today. There's also 1 to the left. So -1, something. Ooh, this is going to be really, really tricky. I wonder who's going to get this one. When I plug in -1, what is the height? What is the y value?
Maybe.
Andrea,
Is it half?
it is a half.
Drea's so smart.
Tell us why.
That was so nice, Stego.
Yeah, you're such a sweetheart.
You deserve it, Drea.
Thank you.
Why is it 1/2, Andrea?
Because it's a negative exponent.
Yeah, so 2 to the -1 is 1 over 2 to the power of +1. This is the time where you're going to ask questions, otherwise you're going to get lost. Ask questions now. Mr. Sindel, how did you get a half?
Yeah, how'd you get a half?
Good question, Evelyn. So, when we plug in when we plug in -1, I get 2 to the power of -1. Nod your head yes.
Sure.
Yes.
Okay, there's this rule that says I can do 1 over 2 to the power of +1 and when I have a negative exponent.
Oh.
This number and this number match, you just have to flip it, and 1 over 2 to the power of 1 is just 1/2.
Oh.
All right. So on Khan Academy, you will be responsible for graphing 2 points and the asymptote. By the way, an exponential function always has a horizontal asymptote. A horizontal asymptote. What number can I never be?
0.
0.
I can never be 0.
I said that too first.
I said it first.
So you can do a rough sketch here, but do a line right here at 0, at y equals 0. The horizontal asymptote is y equals 0, which means, again, the definition for an asymptote is I get closer and closer and closer to that point without actually touching that point. So really, really close to this asymptote. It's obviously getting closer and closer on the left-hand side. Not on the right-hand side because this is shooting offward to like infinity, right?
Sure.
Yeah.
So let's do our best to sketch this. Our sketch is going to have to go through these 3 points.
Yeah, I can't. Wait, I got you. I haven't.
And it's going to get closer and closer and closer to the x-axis. Let me try a better line. Closer and closer to that x-axis along that horizontal asymptote y equals 0. So that's our first parent function, an example of a parent function. Let's try another parent function. So far, I just want to get as easy as possible. The graphical effects is where things start getting juicy. All right, so g of x, spicy also, and all of the other terms that describe meat. All right, steak, I don't know. All right, so this parent function, oh, by the way, can we label this function that we just wrote here? We'll label that f of x, because we're going to draw two graphs on here. We're going to graph g of x on here at the same time. So what points can I choose now? So if I do,
That voice cracked.
I know, my voice is just gone today. I've been yelling at other people. Maybe, yeah, too much. When I plug in 0, what is my output? If my input is 0, 1/3 to the power of 0, quiet raised hand, what is my height? Eva. There it is. Anything to the power of 0 is 1, which is a really nice point. That means for any exponential function or any exponential parent function, I will always, always, always have 0, 1. Things start getting a little bit difficult on the sides here, but I think we can get it. Let's see what happens when I plug in 1. When I plug in 1, what is the height? Fiona.
Wait.
When I plug in 1 to x, 1/3, yeah. And in normal mathematics, that's okay. It's just kind of hard to graph 1/3. And specifically on our homework tonight on Khan Academy, it does not go to 1/3. You have every half, which means I cannot graph this point 1, 1/3. I could graph -1.5, but I can't graph 1/3. Which means I would need to use the second point for this one. So I would use -1 instead. This is probably the hardest question I can ask about these parent functions. When I plug in -1 for x, what is my output? Gio.
I'll take it back.
Andrea.
3.
It is 3.
Obviously. Okay, no.
Again, if you don't know why, I will write it out here to the left-hand side. So 1/3 to the power of -1 means I flip the inside. I flip the inside so it becomes 3/1 to the +1. Whenever I have a negative power, that just means flip or take the reciprocal. And again, the horizontal asymptote is going to be the same. It's going to be y = 0. Do your best graph of these points. So I'm going to make these points in green. So 0, 1 is that same point. 1, 1/3 is right about here. -1/3 is right here. So my graph is going to look like this. It's going to come through this point, through this point, through this point, and it's going to get closer and closer and closer to that x-axis. And that is the graph of g of x. Notice the difference between them.
Wait, hold up. I don't see the points.
So I see there's one point right here at 1/3. The same point, 0, 1, it's always going to have 0, 1. And this -1, 3. So I didn't agree. So it's kind of interesting. So if you look at our base, 2, if it's bigger than 1, then it's going to be exponential growth. If it's between 0 and 1, like a fraction, I mean, a fraction is still 4/3, but I'm thinking of a fraction between 0 and 1, then it's going to be exponential decay.
Okay.
Makes sense.
So far, so good?
Yes.
All right. Here we go. This is where it's going to get hard. This is where I need your full participation, your full effort, your full focus. All right, what I'm going to do here is I'm going to label the steps on this function. Here's an example function, and I will tell you step by step how do I graph this. So first, man, voice is gone. Graph 2 points of the, what did we just talk about? Quiet raised hand. Quiet raised hand. What did we just talk about? 2 points of the, starts with a P, then an F. Eva.
Parent function.
There it is. Write it down. Parent function.
Oh.
So we just learned about the parent function. Hopefully we can graph at least 2 of those points. Thank you, Eva. I gave you 3 of those basic points. We can hopefully graph 2 of them. The reason I gave you 3 is because sometimes you get this thing where you have a weird fraction that you can't graph. All right. Then we're going to horizontal translate. So what we did right now is we did step 1 was using this base. I'll write it up above. Step 1 was using that base. That is our parent function. Our parent function for this one is 2 to the power of x because the base is 2. We can all nod our heads. That makes sense. 2 to the power of x should be the parent function. Nod our heads, nod our heads. Uh-oh. Chris, are you okay? All right. Next, step 2. I'm going to horizontal translate by the opposite.
Not yet. Math is just so beautiful.
By the opposite of the constant in the exponent. So this is step 2 that I'm talking about right here. I'm referring to this 3. What's happening here is normally I'm going to add 3. So horizontal. What does horizontal mean? Does that mean up and down or left and right? Quiet raised hand. James. Try again, James. Up and down or left and right? There it is. Everyone do an arrow like this, left and right, above horizontal. So you know horizontal means left and right. And what is another word for translate? Let me come back and give James his XP. Translate. What is a less mathy word for translate? And you want to see Mr. Sandell translate?
Move.
Slide to the left. Cha-cha, real smooth. All right. So translate, I'm going to put above that, move. So what's happening here? What's happening here on step number 2? Step 2. This 3 is in the exponent. So I said the constant in the exponent. This is a constant, a number, in the exponent. So on step 2, I'm going to move. Is this going to be right 3 or left 3?
Right.
It looks like right 3, but I'm going to do the opposite.
I said left. I said
You
left.
said left.
I said nothing.
Yes, I got left.
So normally I would go right because plus 3, but because it's the opposite of whatever's up here, I'm going to go left 3. So here's an example. If I did x minus 5, that would be left 5 or right 5.
Right, but
That would be right 5. Write it down. All right, here comes step number 3. It's still in the exponent. And the reason that I'm going through these in these orders is from PEMDAS. I'm just going from the top to the bottom. There is no parentheses, so I'm doing exponents first. I'm doing exponent, exponent, and I'm going to do multiplication, then addition. So I'm just going through PEMDAS. So step number 3. If I have a negative x, sometimes I don't have to do a negative x, so I can just eliminate step 3. But sometimes I do have a negative x, then I'm going to reflect over, take a guess, quiet raised hand, x or y, you got a 50-50 chance. Quiet raised hand, Geo. Guess again.
X. I said that the first
X.
time.
Good job, Geo. You got
yeah,
it.
good job, Theo. That sounded like Stephanie.
Yeah.
So again, a reflection across the x-axis means if I was over here, it is now flipped over to this side.
I think I'm
It's
gonna
just a reflection, like a mirror.
Or that's the Y. Yeah. XP?
Oh my gosh.
Oh, so I was right the first time.
I'm so sorry,
I'm
Geo.
gonna read
That's what I thought.
I am so sorry, Geo. It is the y-axis. I don't know what I was saying. You are totally correct. Across the y-axis.
So
Apparently, I don't know my axis.
Wait, do we get like some extra speed or something?
I think Fiona does. I don't know. You should correct me.
I think we all deserve something.
Yeah, mine is value. I felt.
Yeah?
All right, y'all got 70 XP.
Woo!
So, again, the rule is, Chris, if I have a negative here, this all flips over the y-axis.
No, it's the X.
Are good?
Yes.
Don't confuse me, Gio. All right, now we're on step number 4. Multiply the heights. So I'm doing PEMDAS. Now I'm doing multiplication. This is step 4 for number 4. Step 4, I'm going to multiply each of the heights by -4. So if I had a positive height and I multiply by a negative, I now have a negative height. So, heights. What are heights? Is that the x-coordinate or the y-coordinate?
Why?
It is the y-coordinate. Everyone write it down. So you're going to multiply the y-coordinates. What's up? I think so.
Was that
I'm just checking.
She doesn't want to have to erase.
So I don't.
We need to get her an erasable pen.
Of course.
And I already said this. Let's see who can answer this with a quiet raised hand. If the height multiplier is negative, if this number is negative, then reflect over the what axis?
Theo, you're so good at that.
You got this.
Gio, you got this. Let's do it.
X.
It is the x-axis.
Okay, are you sure for this one?
I am sure for this one, and I will even demonstrate it. That means if I have a negative 4 here, not only does it stretch out the function by a factor of 4, but it also reflects over this x-axis.
Okay.
So far, so
Just
good.
making sure.
And then we are almost done. The last thing that we haven't touched is this +1, so that's going to be step 5. Step 5 is adding the 1. And again, that's going to vertical translate. So vertical, is that, what is that?
Up and down.
Up and down? Okay, so let's do the up and down symbol.
Like nice talking.
Up and down.
You don't even know
I'll feel it, you know?
Jody, you know it?
I know.
And then again, what is another word for translate that's not slide?
Move.
Move.
It's move, yes.
Move.
So it's going to move my function up or down. Okay, notice what, there are 3 things, and I told you at the very beginning, there are 3 things on Khan Academy that you need to be able to graph. 2 of them are points. What was the last thing?
Wait, there are 2 points?
Wait,
The horizontal asymptote.
That's the thing that's also going to move up and down on that last step.
Oh.
So on the last step, this will also move up and down with the function.
Is it going to be?
So if it was +1, then this will shift up to 1.
Oh.
It's not reverse or anything, it's just straightforward. If it minus is 3, it goes down 3.
Okay, that's
Okay.
I like that.
No, it makes sense.
That's the last step.
Yeah, the last step is.
So move the asymptote 2. Bless you. All right, so let's try this out. We're going to have 2 examples. I'm going to do this example right now, and then we have 1 example on the back. So we essentially have 2 examples. I know this is called example 1, but I want to try this one with us. So we're going to be graphing over ourselves quite a few times. I wish I could put on 5 different graphs for 5 different steps, but I only had room for 2. Easy. All right, so first we're going to do 2 points of the parent function. So our parent function was 2 to the power of x. 2 volunteers. Actually, 1 volunteer. 1 volunteer. What are the 2 points on the parent function 2 to the power of x? Go for it, Fiona.
Wait, I take it back. I don't know.
It's literally written down on the very beginning.
Oh, 0, 1.
So 0, 1. I just graphed that. Everyone else graph it as well. 0, 1 and
1, 2.
1, 2. Those are really nice points. Thank you. And then where's our vertical asymptote? Or sorry, horizontal asymptote?
0.
At 0. So this gets closer and closer to 0.
You have to do the line or not?
You eventually do need to do the line. For now, we're going to leave it off because otherwise it's going to get messy. So this is our parent function. Okay, now we're going to move some things. So step 2, move. I'm moving where now? I'm moving those 2 points. These 2 points, I'm going to move where? I'm doing +3. Quiet raised hand. +3 means, Andrea?
To left 3.
Left 3. All right, so my new points, again, you're going to have to do it on the same graph. So I'm going to go left 3. 1, 2, 3. There's my new point. My point was here. 1, 2, 3. There's my new point. Here is my new function.
Mr. Sindel,
Yes.
can I have, do you have any pens?
Erasable pens? Or just pen pens?
Different colors.
I don't have different color pens. Sorry. I have black.
Can I have a black one?
But then I have to give everyone else a black one.
Was that that? Ooh, that was that. Like, it's been really sassy.
We just did step 2. Now I'm on to step 3. Do we have a negative x?
Yes.
Then I'm going to have to reflect over the y-axis.
Wait, wait, what?
Oh.
So I'm going to do this. This is going to be the last thing that I do on this graph. So this point was at 1. Sorry, this I had it at -2, 2, but I'm going to reflect over the y-axis. So I'm now going to have it. I ran out of room. I'm going to do it on the second graph over here. I now have a point at +2, 2.
Wait, what happened?
So this point right here got reflected over the y-axis. Yep. So it's now over here. It got messed up a little bit. This point also gets reflected over the y-axis. So there is what my function looks like after step 3. And again, the asymptote has not moved. This is step 3. Notice that I'm really only doing these operations on those 2 points over and over and over again. Which means I could do 1 point, all of those steps, and then do the next point, all of those steps. I'm on to step number 4. I'm going to multiply the heights. So, my multiplier now is -4. So if my height was 2, this new height is...
-8.
There it is, -8. But it's still the same x. It's still the same 2. It's going to be all the way down here at -8. This height was 1.
Wait.
That's a lot to like so many steps.
I know.
Can I just like
If you multiply the,
cut this out?
isn't it -6?
So I'm multiplying -4 times 2.
Yeah, you get 8, but you're going down from the 2 to whatever.
You just straight on multiply it.
To the negative.
You don't shift it, you just multiply it. Alright, and then this 1, it had a height of 1. 1 times -4, -4. So I come down here to -4. There is my new function, still having the horizontal asymptote right here at y equals 0. There's my new function after step 4. And then finally, this is the last step, and it's usually the easiest step. The last step is to vertical translate, which means move. I'm moving up or down 1. Up 1, which means the asymptote now has changed. This point was here, now it's right here. This point was here, now it's right here. And the asymptote I'm going to actually draw for my final line. My asymptote is right here.
Hi, Lori.
Just call me trash man.
No, I called you
You know
Lori.
what, you guys, there's been 2 mice found in the school today. Dead, you know, so we need to stop eating in class and, oh really, there's 2 dead, you know, there's serious mouse.
Teflon.
It's still your fault.
So, the trash hasn't been done.
Alright, ask me questions now, because this procedure is kind of complicated. I will show you a few shortcuts, but not all of them. Yeah, Stego.
So, you know how we did there was 2 graphs, and like how we did step 1, step 2, step 3, step 4, step 5, you know what?
Yeah.
Is it all
Alright,
in
you're
one
gonna
graph?
answer all my questions right
Like
now.
we have to do all the steps to get that.
To get that one
This
graph.
all are-
Yes.
Wait, so then what's our answer?
Our answer was this red graph, step 5.
Oh.
Where do you? Where? I didn't see it.
The asymptote?
Yeah.
Alright, so on step number 5 says move the asymptote, and we were going to move up 1.
Oh. Wait. What about this line? Go down. What about the red? Yeah, that one.
So each of these points moved up 1. This was here, and it moved up 1.
Oh,
This
okay.
was here, it moved up 1.
Not yet. Okay.
Yeah, so when I'm talking about moving up or down, I'm talking about moving the points and the asymptote. You can just hold on to it until the end of class.
No, I don't want to.
Okay.
Push up.
Are you on the softball
No, you're
team?
supposed to throw. Oh. Well, I didn't want to hit you.
Okay. Let's try one more example. I will show you a shortcut.
I'm sorry.
One more example. I will show you a shortcut. Here we go. James, let's go. James, give us 2 points on the parent function 1/2.
1.
0, comma,
1.
0, comma 1 is always on every single graph. And what happens when I plug in -1? What's 1/2 to the power of -1? 2. So -1, comma 2. Thank you, James. All right, James gave us the first 2 points. This is on the parent function. I'm not even going to finish graphing what this looks like. I know that everyone's like, oh yeah, it's going to look like this. And you can visualize that. My voice is breaking. You can visualize that in your head. But for now, I'm just going to graph the points because it's faster to just do the points. So these are my points after step 1. Okay, then I'm going to do step 2.
Bro. I didn't know we were doing this. I don't have it. I think you should hand it to me. Shut up.
All right,
That was rude.
I'm going to do step 2, 3, 4, and 5 just to 1 point. So
I guess that's too bad.
I will.
I don't know what it is.
Well,
We will not have homework tonight. We will finish this tomorrow. All right, so this is now Wednesday, May 1st. My voice is totally gone.
Review.
We left off by saying if I take the reciprocal of, okay, I don't want to talk over you guys. It's really hard to talk. And you're making me talk over you. Again, if I take this power to a -1, I have to flip the inside. So it becomes 2/1. Therefore, I have a height of 2. And then, Chris, you're maybe understanding why that's 2 now, yes? Okay. So that was only step 1. I also need to do step 2. What was step 2?
Horizontal translate by the opposite of the constant.
So it's your 2 and
Move it left 2.
Left 2. Okay, let's do that. So left 2, 1, 2. Left 2, 1, 2. So what we just did right now is step 2. Again, I'm only going to draw the points. I'm not going to draw the function because that's just too much work. All right, step 3. What am I doing?
reflect over the y.
Reflect.
It's negative, right? If negative x, reflect over the y.
Right. So this is now being reflected over. This was at -3. It's now over here at +3. This was here at -2. Now it's over here at +2.
Did you just flip it?
Yeah, we reflected over the y-axis. What's next? Say it louder.
Go up 4.
That's not quite there yet. We have to. Okay, let's check off what we've done. Checked. Check. Check. We have to do this one next, then this one. Yeah. So multiply the heights by -3. So I had a height here of 2. Now it's a -6. So it's still the same x at 3, but now I come down here to -6. I had a height of 1. It's now at -3. That is step number 4. Now finally, I'm going to do what?
Shift the points like
Shift them up 4, exactly. So I was here at -3. I'm going to go up to 1. So I'm going to do a red circle so I don't draw over the same dot. And then this was -6. Is going to come up here to -2. So these 2 red points right here and here are step number 5. All right, question for XP. Where is that horizontal asymptote?
It's like right in that thing.
Y equals what number? Geo.
Hold on. 4.
Yep, y equals 4. So everyone make a line. You can just sketch it. It's y equals 4, this flat line right here. Which means if I'm actually trying to sketch this thing, it's going to get closer and closer and closer to it, and then eventually come down through these 2 points. In fact, I'm probably going to just do that over here on this new graph, since we haven't used this new graph yet. So at y equals 4, we have our horizontal asymptote. We have this point here at 2, 1, and 3, -2. And do your best approximation. Yeah. And there is that function.
Yeah.
Okay, let's try some on Khan Academy. You want to try some with me first?
Yeah.
All right. And if we're getting too hung up on the digital graph, then I'll show you either a new technique or we'll just do it on paper. Go, computer, go.
Is the assignment up in?
It is, yeah, if you want to do it on your own. What's up? Okay, I'll give you a replacement. All right, so on each of these, because we're in a logarithmic, because we're dealing with our unit of logs, you have to choose between a log graph or an exponential graph. This is always a log graph and then exponential. So which one is this? Is this exponential or log? It's not a trick question.
What?
Is this function exponential or logarithmic? Do you see a log in it? It's not a log, it's not this one, it has to be this one. So everyone's going to choose the second one.
How do you know it's logs?
If it's a logarithmic graph, it will say log.
Oh. I knew
So
that.
very tricky, I know. All right, so I'm only going to deal with 1 point at a time here. So let's deal with this point right here. This point is at 0,1. Is that a good starting point? I need to graph the parent function 1/3 power of x. Is this an okay point?
Yeah.
Okay, where should this point start?
-1,3.
Is it 1,3 or -1,3? Everyone has to be on the same page. Why is it -1,3?
Because if it's not a negative, then it's going to be a fraction, and it's a fraction.
Exactly. So I need to flip it, so I need to have it. Okay, I'm only going to deal with this point for now, and then I'll do this one later. This point, I'm going to first do what?
To the left.
The left 2. 1, 2. Okay, I just went left 2. Next, do I need to reflect that over the y-axis?
No.
No. Next.
And you don't do that because it's not negative.
Next, what do I do with its height?
You multiply it by 2.
So instead of 1, it is
2.
2. Okay, so I'm going to move this up 2.
Are we doing 1 point at a time?
Just 1 point at a time.
Okay.
Then finally, what do? Move it down. Move it down 1. So I move it back down 1. By the way, where is my horizontal asymptote now? So I'm going to drag this one to -1. Okay, now I need to do the second
Oh,
point.
me.
The second point.
Okay,
So
left to
left
the
2.
2.
It goes left 2. 1, 2. Okay, then what? So I just did left 2, so I'm dealing with this one.
Multiply it maybe up to 6.
Up to 6. All right, let's do it. All right, and then finally,
Go down 1.
go down 1.
You went down twice.
Ooh. Yeah.
You're doing the same thing over and over. You can just make sure that you set up the parent function first, and then just drag 1 point, do all the operations on the other point.
Yeah, but once
Yeah,
I get on
when I
it,
do, I'm like,
it
oh.
doesn't look like that.
Okay.
It's like,
Yeah. Let's go ahead and try it now.